Hi, everyone. Welcome to today's talk. Our speaker is Nguyên Hoang. After obtaining an engineering degree from the École Polytechnique in Paris, Lei received his PhD from Polytechnique Montreal and then became a postdoctoral researcher at the Massachusetts Institute of Technology. After this, he became a computer science researcher and a science communicator at EPFL. He also runs the YouTube channel Science for All with over 200,000 subscribers and the podcasts Axiom and Robustly Beneficial. He's also the author of several books that I will note in the video description. More recently, he launched Tournesol, a platform for collaborative content recommendation, which is the topic of his talk today. Lei, I'm really excited to have you. I will let you take it from here.
Thank you. Thank you for the introduction. I'm happy to be talking, to have this occasion to talk. First, I'm going to discuss a bit of the poem before presenting, hopefully, Tournesol as a solution, hopefully, to the poem. So the poem I really have in mind is algorithmic recommendations. And just to have an idea of the kind of dilemma I have in mind, you can imagine what happens when you search, for instance, for is climate change a hoax on search engines, so for instance, here on Google. Well, if you like, I think this is an interesting audit to be done every now and then, just to understand what is recommended by the different platforms on the internet. And if you do this on Google, then you will find out that Google is actually pretty aligned with the scientific consensus. Like the first at least 4 links, I haven't checked all of them, but like they're pretty aligned with the scientific consensus. They will say no, climate change is not a hoax. But if you do this on other platforms, like for instance Microsoft being here, the first 2 links, actually even third links on investors.com, these are actually saying kind of yes, or like really yes, some of them. It is a hoax. You do have this snippet from Wikipedia, but yeah, so this may be, like, this is arguably not fully satisfactory. So this is yahoo.com, where you have a link that's promoted that says climate change is a lie. So again, not ideal. DuckDuckGo is also essentially answering yes, climate change is a hoax. At least the first 3 links. The 4th one is Wikipedia. Ecosia is a search engine that's trying to, like, that's aimed to be aligned with environmental concerns. But again, like the first links that are recommended, well, they're all the same as Bing.com actually. And so they are saying essentially, yes, it's a hoax. And finally, YouTube, well, for this, well, at least YouTube is aligned with the scientific consensus, and they will recommend videos that says no, climate change is not a hoax. What's going on here actually is that Google and YouTube have announced 2018-19 that they were going to fight misinformation, and this is likely a result of an active effort from them. And what I would want to stress to this example is not that Google or YouTube is good. I've been criticizing them a lot lately, especially after what they did with the ethics team. What I mean to show here is that if there's no active effort to try to make sure that the answers of recommendation algorithms or search engines are what we would want them to be, or aligned with scientific consensus, or something that's positive for the future of humanity, then there's no reason why these algorithms will be aligned with here, like reliable information, for instance. And in fact, it's even worse than this, because these platforms are like constantly under attack. Like SEO optimization, so search engine optimization, has been a thing for at least 20 years, or at least 10 years, I'd say. People are trying to be on top of these recommendations, and there's a lot of efforts to sort of hack these recommendation algorithms and to promote one's views. And in fact, another way to look at it is that whenever they are queried, these algorithms are actually faced with dilemmas. And it's not only about being true or false. When someone is actively searching vaccination kills on YouTube, for instance, it's actually a very difficult question to know what video should be recommended. And in fact, in the beginning of the COVID-19 situation, I was exchanging messages. I was messaging a friend of mine who's working at Google, asking him to make sure that the algorithm is not going to promote false information. And at the beginning of COVID, there was a lot of this. And then at some point he asked me, okay, what video should be recommended? And it's actually not an easy question. In particular, when someone is searching vaccination kills, then probably he's in a mindset where he wants to be confirmed, like he wants, like there's this thing called confirmation bias. And so if you just promote a video that is not a good defense of the effectiveness of vaccination, and that does not discuss carefully the potential risks of vaccination, then there's actually a strong risk that the person that is consuming this content will actually reinforce their belief and will keep believing that the vaccination is dangerous or kills. So it's actually, what I mean to say is that it's really a dilemma at some point to know what will be recommended. And so, like most of the time when these algorithms are queried, it's not going to be a matter of life and death. Like most search queries, if you're searching for croissant, I don't know, like it's not going to be a matter of life and death. But the thing is that these algorithms are queried a huge amount of time per day. I call it like the n times epsilon effect. Like every recommendation is a small effect epsilon, which may be small, but there's just a huge amount of them. And what's very difficult to understand when you have this n times epsilon, when n is huge and epsilon is very small, is that it's very hard to predict whether the product of these two is going to be large or small. Like you somehow actually really need to do some estimate to better figure out if it is something that should be of concern or not. And if you compute the number of responses that these algorithms make, this is actually a very huge number. These algorithms are making billions of recommendations per day. So if you multiply this by the number of days in a year, for instance, you quickly get to thousands of billions or trillions of recommendations, and that's really a lot. Now, the example I've given here is actually quite misleading. I think it's a nice example to start with, but it's important to keep in mind that actually what's going on these days is no longer so much this kind of searches that users are making. Well, I've seen a figure, so I guess, a figure today that most people don't actually click to any links. They just, like, I think it was almost like 2/3 of the time, or maybe not 2/3, it was more than half of the time. When people search something, they just look at the answers and then they quit the window. So it's very important to make sure that what is shown, and especially if there's some snippets integrated, is like this is what's going to determine what the consumer is going to conclude. But now, actually, more often than not, people are no longer searching for information. They actually rather follow what the algorithms are saying. Just to give a few figures, since 2016, actually, so it's been 5 years now, there are more views on YouTube than searches on Google. This really astounded me when I discovered it, and it's been quite a while. This was one of the arguments I used to convince CPFL to give me a job. Another important figure is that 2 times out of 3, when people watch a video on YouTube, it is because the algorithm, the YouTube algorithm, has recommended this video to them. So more often than not, the views result from algorithmic recommendations. And this all adds up to, so these are like 2019 figures, 1 billion hours of watch time per day for 2 billion users, or half an hour per day in average. And again, this is 2019. Yeah, I hear here and there that well, with the pandemic and the lockdowns, like these figures have just exploded. So this is becoming extremely influencing. Just to stress again how big the difference of the views of different videos can be. So essentially here on the left and right, like so I published a video, and on the same day I have a colleague who published another video, and my video got recommended a lot by external sources. So it made almost 40,000 views from external sources. So it has been widely shared on social medias. Whereas my colleague's video had 12,000 views, so like 3 times less. And yet her video made like a lot more views, like 300,000 views, and mine did 80,000 views, something like this. So this really shows that like these recommendations are really determining whether a video is going to be seen a lot or not. Coincidentally, this was a video that I made that was critical of YouTube and Google. So what are the consequences of this? I think that there are more and more concerns about just misinformation. The amount of misinformation out there is, I think, extremely concerning. We can see this, for instance, in the case of anti-vaccination views. So this is a paper in Nature that was published in May 2020. And so if it was published in May 2020, it means it was accepted a few months ago. So this is a paper prior to the COVID-19 pandemic. Arguably, things have got worse during the pandemic. I guess we'll have more data in the coming months or years. But already with like essentially 2019 data, there were huge concerns about anti-vaccination. So in this paper, they created a model where they analyzed what's going on Facebook groups, and they fit a model. And with the model, they predicted that anti-vaccination views would be dominant in a decade. And this is extremely concerning. If you read about vaccination, you know that herd immunity is extremely important to protect all sorts of people who are, so well, I'm not going to do all the theory here, but it's very important that a large fraction of the population gets vaccinated. Otherwise, we can have this epidemic resurgence, especially of things like measles. What I want to stress as well is that a lot of the debate has been about fake news or false information. And I really want to stress that this is not the issue. Like fake news and false information are, of course, a problem. But arguably, they're just a tiny part of the actual problem. And here I'm illustrating with the case. So this is a nice infographic. So sorry, it's in French, but it's a nice infographic that has been done in the case of French media by a Twitter user that essentially collected what were the articles in French medias that got the most clicks. And what you can see here is that all of them are factual. They're all factual information about people who died after they took the vaccine. But it's anecdotal in the sense that it's small numbers of either undesirable side effects or deaths. And the thing is, that if you do the computation, you know that every year, especially old people have like 1 in 100 chance, for instance, of dying from reasons that have nothing to do with in general. And so if you vaccinate 1 million people, then you know that 1% of them is going to die within a year, like 1 out of 1,000 of them is going to die in the next month. So if you vaccinate 1 million people, you expect 1,000 of them to die within the next month. And it's like just for reasons, because for all sorts of reasons that have nothing to do with vaccination. And so like, what I mean to say is that these are information that are actually unreliable. They are factual, but they are actually misleading. I guess this is more the term. And misleading information is a much bigger issue. Factual misleading information is arguably a much bigger issue than false information and fake news. The thing is that this is also a lot harder to study, because it's also a lot harder to identify or to agree on what information can be counted as misleading. Another concern I do want to raise, especially with the COVID-19 situation, is the problem of mental health in general. So there are growing concerns about especially addictive overuse of social medias, and in particular there's something called doom scrolling. It's like scrolling, using infinite scrolling and spending a lot of time doing so. This has been associated with depression, and there are a lot of concerns to be had about global anxiety in general, which is not good, I guess, like for people who are anxious. But it also creates all the undesirable effects. Like, so for instance, this excellent video by Kurzgesagt accounts for researches that have been done about the association between loneliness and aggressivity. So if you feel more lonely, more anxious, then there's a greater risk that you're going to be also more aggressive on social medias, and this can deteriorate the quality of public discussions, which can then lead to bad decisions and so on. So this is also an important concern for other reasons than just mental health, but of course, mental health itself is a huge issue that has been underlined by the World Health Organization during the COVID-19 pandemic. So hopefully I've convinced you that there were problems with the algorithms that are massively deployed today, especially recommendation algorithms. And I'm going to move on to ideas of solutions or moving towards solution. And yeah, hopefully, as I'll go, you'll be more and more convinced that Tournesol is necessary to actually solve the problem. So one solution that has been discussed, and I think it's more and more the case as algorithms are becoming harder to monitor, to understand, especially using deep learning and having these trillion parameter models, stuff like this. Like the way we can control more of these algorithms, especially something like the YouTube algorithm that takes billions of decisions per day. It seems that the better way to control them is to make sure that their objective function, the goal that they are designed to optimize, is going to be to contain human preferences and to be aligned in particular with human preferences. So today, the YouTube algorithm is unfortunately not designed to take into account all sorts of complex human preferences. It's rather optimized to make a lot of views. I should note that this is, well, I want to note rather that this is not specific to algorithms, making sure that the goals are aligned with what we would want different entities to optimize is something quite ubiquitous in economics and organizations in general. Democracies, for instance, want to make sure that our democratic representatives are really optimizing for what we would want them to be optimizing and not, like, for instance, their personal gains. Same thing for institutions and companies in general. And I've made another note here of volitions rather than preferences, because arguably, like, the YouTube algorithm is already designed to optimize for instinctive, immediate preferences. They optimize for what we would prefer to click on, in a sense. But arguably, that's not what we would really want to optimize. So the examples I always take is me watching football videos. I tend to be able to watch videos about football for a very, very long time, and to regret it after that. So, like, immediately I have this preference to click on this football video, but if I think a bit longer about this, I would be like, okay, I want to click on this, but I would want not to want to click on it. So sometimes this is called an order of second order or volition. By the way, feel free to ask any questions along the way. I'm happy to take questions. So if you look at today's algorithms, they're really optimizing for click-through rates or click on ads or watch time in the case of YouTube. And this has been argued to have very nasty consequences. Essentially, this is promoting the very addictive content. And addictive contents are not necessarily or usually not very quality informational content. Now, one issue that we quickly encounter when we're trying to think about what these algorithms should be doing, what content they should be recommending, is that this is a question of ethics, and ethics is widely, longly debated topic. You have books and books and books written about ethics. It's complicated. There are different views. We don't necessarily agree. And above all, I'm going to take a computer science point of view on ethics here, computational point of view, and by that, what I mean is that I'm going to formalize the notion of complicatedness, of complexity. So in computer science, we have different notions of complexity. And one of them is called the Solomonov complexity. Maybe you've heard it as Kolmogorov complexity. So this notion of complexity is the minimal number of lines of codes that you need to write down in order to solve a problem. And so in our book, which I'll present later on, with Almadi M. Hamdi, professor and a researcher at Google, what we make one conjecture, one thesis is that if you want to write down a computable, satisfactory moral philosophy, then it's going to be complicated in the sense of Solomonov or Kolmogorov, meaning that it will be a huge number of lines of code. So what we wrote down in the book is, in our book, is you will need at least 500 pages to write it down. But if you read the book, intuitively, what we have in mind is more like 1,000 books would not suffice to write down this moral philosophy. And so why do we make this claim? To understand this claim, you can think of like one thing you would want to say. Typically, I think we can, most of us at least will agree that torturing cats is not desirable, is not preferable from an ethical point of view. But so like any satisfactory moral philosophy arguably should contain this idea that torturing cat is not good. But formalizing this idea is actually very hard because you need to define what a cat is. And if you are to define what a cat is, at least you probably need an algorithm that's able to recognize cats in images. But computer scientists have tried again and again to write down an algorithm that's able to identify cats in an image. And over the last 70 years of computer science, no computer scientist has ever been able to write down an algorithm that's able to recognize cats in an image. And in fact, interestingly, this was anticipated by Alan Turing in his 1950 paper. So it's a brilliant paper. So it's the paper where he discusses the Turing test, which you've probably heard about. But one thing that's maybe neglected is that in this paper, one thing that he did that's I think much more important than the Turing test is that he introduced the idea of machine learning. So fun fact, machine learning was invented before artificial intelligence was a thing, because people often associate artificial intelligence with the 1956, so 6 years later, summit. And what's even more interesting is why Turing thought that we needed to do machine learning at some point if you want to solve complex tasks. So what he had in mind was the Turing test. The example I'm going to take here is recognizing cat in a picture. And the reason why Turing said, well, we're going to need to do machine learning to recognize cats in a picture is because he argued we cannot write down the algorithm that's able to detect cats in an image. And the reason why we cannot write it down, according to Turing, is because it's just too long to write. It's just too many lines of code. So in his paper, he had this estimate. Again, he was thinking about the Turing test, that you would need at least 1 billion lines of code to solve the Turing test. Now, 1 billion lines of code, that's a huge amount of lines of code. And that's the equivalent of 1,000 books, like even more, 10,000 books, let's say. The book is about 10 to the 5 lines of code, let's say. And writing 10,000 books, well, no human can do this. In fact, it would be hard even for a group of humans. So in this paper, he talks about having a team of 60 workers, and he estimates that given his current rate of writing programs, it would take 50 years, and assuming that the code is always correct and perfect, which, as we all know in practice, is never the case. So clearly, this is a very difficult task. And that's why he says some more expeditious method seems desirable. And the idea he had in mind is machine learning. So in Turing's view, machine learning is a solution to writing very long code. Instead of writing them yourself, you're going to write a way to write the code, to let the algorithm write the code itself based on training data. And he already had all of these views back in 1950. That's why I really, really admire this guy. Now, an important consequence of machine learning, and like machine learning today is like ubiquitous, especially in recommendation algorithms. It's used throughout all recommendation algorithms. One big consequence of this is that we used to think that algorithms manipulate data. And because of this shift towards machine learning, it's really, really important, I believe, that we take the other view that now data is also manipulating algorithms. Not only algorithms are still manipulating data, but also data is manipulating algorithms. And so if you want an example of this, let's skip this. This is particularly obvious, I'd say, in the case of what's called now large language models, so these huge algorithms that learn from a huge amount of textual data. These algorithms are really learning from all their data. Like they memorize the data that they train on. And this raises all sorts of concerns because like all of the data is then contained, is known by the algorithm. So there's a huge privacy risk. So typically if Google is training its algorithm based on emails from Gmail. And yeah, so far like it's like Google is not communicating that they're not doing this. So I tend to be, to assume the worst, let's say. If they're doing this, at least it means that the algorithm that Google is using and maybe deploying knows about what was in your private emails. And in the worst case of this, you can imagine that maybe someday when you're going to search something on Google about maybe an ex-girlfriend of yours, that maybe the information, like you will receive information from Google that was derived from the reading of your ex-girlfriend's emails. Of course, maybe this way you'll be happy, but try to imagine like the other way around. Yeah, so I think this is a really, really big concern. Another concern is misuse or just like manipulations of these algorithms. So there's the paper on the right, what they show is that if you just prompt these algorithms based on you're asking them like what is QAnon or something about or some conspiracy theory. If you're asking them the right way, like essentially if you're asking them the way with the kind of phrasing that is found in conspiracy Reddit groups or subreddits, then the algorithm is going to respond the way people respond on this subreddit group. So if you talk like someone in this subreddit group, the algorithm is going to, well, reply very conspiracy kind of responses. And again, this is a big concern. If you imagine Google is deploying this kind of technology, then the answer it will provide to someone searching something on Google. If the person is searching the way people are asking questions in this kind of subreddit, then the answer promoted by Google may be something that's going to be of the same kind of this subreddit. So this is arguably a big concern. Yeah, I'm going to insist again on this idea that training data, particularly really control algorithms these days. So you have this user on Twitter, Abid, who tested GPT-3, which is one of these large language models, by prompting it by talking about two Muslims. So you see, every time he writes a new sentence, a new prompt, like two Muslims walking to a mosque, for instance, and consistently GPT-3 is completing these sentences by talking about terrorism or murder or death. And so GPT-3 is consistently matching Muslims and violence. And again, you can ask, why is it that he's doing this? And again, it's not because of the programmers. I think we give a lot of importance to programmers, and rightly so, but we should give arguably even more importance to the data that the algorithms are trained on. The data, in a sense, are controlling more the algorithms than the developers are doing these days. Of course, the developers still have a lot of influence, but in terms of number of lines of codes that are derived by the influence of the programmers or of the data, there's an argument to be made that the data is much more influential. In any case, like in the case of GPT-3 is completely manipulated by its data, and this data is telling GPT-3 to constantly associate Muslims and violence, and that's why the algorithm is constantly also mapping Muslims with violence. Perhaps no other story illustrates better the idea that data control algorithm than the tale of two AIs called Xiaoxie and Tay. So I'm guessing you might have heard, or you probably have heard of Tay. Tay is this chatbot launched on Twitter by Microsoft. And Tay was supposed to be this teenager, like acting like a teenager and being nice to a lot of people. And Tay was turned into a troll, into a racist, genocide, sexist bot that was insulting everyone and calling for genocides of different minorities within 16 hours, like very quickly. And so you can ask why did this happen? So, of course, I don't know the details of all of the story. Like some of this is proprietary information, but probably Tay was designed to optimize engagement, to have a lot of ping pongs of exchanges with a lot of Twitter users. And what probably happened is that whenever Tay was saying something outrageous, a lot of trolls were liking, retweeting, replying, and like this was creating engagement. And so Tay learned that this kind of messaging was creating engagement, and so she just replicated. And Tay was therefore like completely manipulated by the data that was provided by the different users, like the other Twitter users. Interestingly, Microsoft, and that's maybe a little less known, Microsoft launched another chatbot called Xiaoxie. I'm not sure about the pronunciation, but yeah, it's a Xiaoxie. And they launched Xiaoxie in China 2 years before Tay. And Xiaoxie was launched on WeChat, Chinese social medias, with the same goal. Like she just trying to have a lot of ping pongs, a lot of exchanges. And Xiaoxie became extremely nice, apparently lovely, to the point that Xiaoxie is now used by 660 million people in China. This is absolutely huge, like in terms of surveillance and manipulation. Also, this raises all the kinds of issues that the Chinese government, I'm sure, is very concerned about. But what's really interesting is that, like, apparently, like there are hundreds of millions of regular users of Xiaoxie, like who discuss with Xiaoxie on a regular basis, and some Chinese people apparently even fell in love with Xiaoxie. And some argue that she's really nice and she has a better than better emotional intelligence than most humans. Anyways, the point I really want to stress here is that these are two algorithms that were probably designed in almost identical manner initially, but they have two different outcomes. And the reason why the outcomes is very different does not have to do with the programmers, it has to do with the training data. Now, the thing is that today's algorithms are constantly fed with fake data that are meant to improve like the recommendations of this or that time of content. So like search engine optimization has been a thing for quite a while. Under my own videos, you have a lot of people who apparently like what I'm doing, who are just commenting just to add, to improve the referencing of my videos. So this is happening under my videos. Like people are creating fake data, like fake engagements, just to promote my video. And like in this case, I'm fine with this. I'm happy about this. But this is also happening for all sorts of very dubious or very dangerous contents as well. Today's algorithms are trained with users' data. And these data are absolutely not reliable. So more generally, one I think very important takeaway of this is that if you're designing an algorithm, and especially if it's designed to optimize a goal, if the goal is computed based on some uncontrolled data, then you cannot consider that this algorithm is safe. An algorithm that's optimized for a goal that depends on data that's fed by all sorts of users and that you do not control should be regarded as very unsafe, as completely manipulable. So AI safety or algorithmic safety or must be, if you want, especially machine learning safety, you absolutely need a safe, secured database. So yeah, so that's the sentence. There is an urgent need of a reliable, secured. It needs to be large as well, because you want to train these algorithms and you need a large amount of data to train performant algorithms. And so we absolutely need this reliable, secured, and large database. And if it's about the goal of the algorithm, we want to solve the alignment problem, then this database needs to contain human preferences and even, if possible, human volitions. Yeah, so that's I guess the big claim if you want to be convinced by Tournesol that this is the big thing. We cannot have any sort of AI safety without this kind of database. And this is where Tournesol comes in. Tournesol's goal, so I call it like a collaborative content recommendation to most people because it's easier, but the actual goal of Tournesol is to create this database. This is really my big concern, is to have a large, reliable, secure database of human preferences. So Tournesol, how does it work? The idea of Tournesol is that we're asking contributors to go on the platform to import videos that they have liked, that they have already watched, if possible. This reduces the amount of effort from their end. And then we're asking them to compare the different videos in terms of different criteria. Actually, this slide is not up to date. They change a little bit the names of the different criteria, but like this is the overall idea. You select 2 videos that you like, and you tell us which one you find more reliable. So actually now it's called reliable and not misleading. Which one you find more pedagogical, which one you find more important, which one you find more engaging, which one is more resilient to backfiring risks, and so on. We have other criteria that you can add by going to the settings of the application. And then based on this kind of data, then we have a very basic machine learning model that's going to, it's based on the Bradley theory model, for those who know, that's going to infer the scores you would likely give to different videos. So you have, so we call it like an algorithmic representative. So the algorithmic representative is like a democratic representative, but it is personalized. So it's supposed to have the same preferences as you. And then to determine the overall score on Tournesol, we aggregate using a median, coordinate-wise median. It's not exactly like this, a bit complicated, but essentially we're using this sort of aggregation to compute an overall score that is supposed to represent, that is designed to represent the contributions of all the contributors to Tournesol. Yeah, so that's the overall principle. Hopefully, by doing this, we can identify the top quality contents on YouTube, and then we can use these to, for instance, audit more automatically the quality of the contents that's most recommended by the YouTube algorithm, and hopefully we also can provide a solution to YouTube, or hopefully maybe in the future have a collaboration with YouTube using, for instance, our scores to promote better, more quality contents on YouTube. But if you want to get there, if we hope to one day get there, it's critical that we make sure that our scores are actually reliable. We need to make sure that they are sufficiently reliable for YouTube, for instance, to blindly trust the kind of data that we have. And this is actually very difficult. So, so typically you can ask, how do you identify reliable contributors? How do you make sure that particular contributors will not be fake accounts? So let me ask you a question, and maybe you can answer in the chat. How many accounts do you think, how many fake accounts do you think Facebook has removed from its platform in 2019? So during this 2019 year, Facebook removed fake accounts. How many fake accounts do you think Facebook removed? What is the order of magnitude? Like, is it in the hundreds, in the thousands, in the millions? What do you think? See, chat, okay. Okay, so there are a few answers, 1 billion, double-digit millions, 50 millions. Okay, so the answer is, actually, I forgot to add the slide, but the answer is 6 billion. In 2019 alone, Facebook removed 6 billion fake accounts. That's almost the number of humans on Earth, and it's a lot more than the number of actual accounts on Facebook. So on something like Facebook, where there's an army of engineers and a policy of 1 account per human user, there are more fake accounts than actual accounts. Yeah, and this is Facebook. So arguably in other platforms, it's a lot worse. So yeah, to protect ourselves against this, we demand, so anyone can create an account on Tournesol, but in order to affect the Tournesol scores, we demand the validation of an email address from an institution, from an email domain to be specific, that we trust. And by trust, what we mean is not like we trust that the domain is a nice people. What we mean is rather that the email domain is not going to create a lot of fake accounts. That's more kind of protection.
Lei, now, quick question. Yeah. Who, when you're talking about we, who is we in the like defining requirements and then evaluating?
Yeah, so like so far, Tournesol is not very legally structured. Let's say it's like a group of us have been working. So let's say 3 or 4 other people and myself have been working on designing this thing. So we're going to be doing like all the necessary to become an association. And yeah, so that's the we that's handling this platform. And so currently, to be even more specific, the person who's deciding whether an email domain is going to be considered as trustworthy or not is myself currently. So, and all of this is made public. So yeah.
Cool.
Another concern that we have is how to protect ourselves from malicious contributors. So even if we have all of the system, like there's still a risk that at least 10% of them, at least one person is going to be malicious. And so yeah, we have designed algorithms that are aiming to be robust to this. So I can talk more about this. So this is a line of research that we have been investigating for several years now. The idea is essentially that you have different here accounts or different nodes, as we call them, and you assume that a fraction of them is what we call Byzantine. Byzantine is like maximally malicious, and we want to make sure that the system is still performing correctly, even though there's a small fraction of Byzantines. And another question that we've been asking is how to incentivize contributors adequately. How do you make sure that they're not going to exaggerate their preferences? And again, this is related to research. So this is not up to date, but and this is not published. But like we were working actively on this. I'll be happy to tell you more about this if you want. But what I mean to say is that we have it's a big research program. Like we have a lot of the big platform design program. We have a lot of open questions, yeah, if you're interested in finding out more, I think that there's plenty more that I could be saying. But yeah, for the interest of time, I'll move to the conclusion, and then you can move more to questions after that. One thing that, okay, so I have essentially 5 messages, I'd say. Like the first one is that Tournesol is a collaborative platform, so it absolutely needs a lot of contributors. There are many ways you can contribute to Tournesol. So hopefully once we are an association, you can contribute by direct donations, which will be used, for instance, to pay our developers and also to promote the platform. But you can also provide, especially if you're watching YouTube videos on a regular basis, you can help us by providing your own ratings to different contents and help the platform identify top quality contents. And of course, like if you want to contribute to the code, so right now the code is not open, but we are in the process of cleaning the code before making it available and open. So we will be able to take external contributions eventually in the next few weeks, months, let's say. Yeah, and also just all sorts of feedbacks and also promotions, of course, sharing this kind of content. So this will be extremely helpful to us. Now there's a lot of pedagogy that's needed. So hopefully with this presentation, I've given you a glimpse of how complex the problem is, but yeah, the problem is extremely complex. The algorithms we're designing and the concerns that we have takes time to be explained. So we also investing a lot in pedagogical contents. So I'm making this series of videos on my channel, English channel, Tournesol. So it's also on my French channel, but it's also available in my English channel. So for instance, the first one was about social media, the danger of social medias, and especially the fact that they're constantly under attacks, and that what you need is algorithms that are robust to these attacks, which is very hard. And so and there's going to be a series of videos explaining both what the social and technical problems, but also like the solutions of Tournesol and the different research ideas that are relevant to Tournesol. You can subscribe if you want to keep checking this. And we also have this wiki on Tournesol where we're trying to document a lot of things, add a lot of resources to connect a lot of content. But as you can see, there's a lot of things in red, meaning that these articles have not been written yet. Because, there's a lot of work to be done. So also that's a way to contribute to Tournesol, is to try to help with the wiki. But I would like to end with three messages that are the three key messages of our book with Madi M. Hamdi, called Le Fabuleux Chantier. Currently it's only in French, but we are working on the translation. Hopefully it will be out in the coming months. And in this book, we defend three ideas. The first one is, hopefully I've convinced you of this in the early part of this talk, is that making algorithms robustly beneficial has become extremely urgent. I think all the causes that you can think about, information is critical somewhere. So if you think about Black Lives Matter, or if you think about climate change, or social inequalities, or poverty, like all of these animal suffering, like all of these concerns all have to do with creating and sharing and especially spreading quality information on the vast scale. And algorithms are what's controlling this flow of information the most these days. So that's why algorithms are absolutely critical, and it's become urgent to make them robustly beneficial. The second thesis, and hopefully I've also convinced you of this, is that it's also extremely hard. Like it's very easy to come up with, in French we call it fausses bonnes idées, so like ideas that seem appealing but are actually not good because they have unwanted side effects typically. And so it's really, really important to think about them carefully and to have a really principled approach that's robust to all sorts of attacks. But most importantly, and I hope that this is something that has transpired in this talk, is that I think that this is absolutely a fabulous endeavor. I think this is some of the most exciting intellectual ideas that I've ever encountered. This is really about designing a global system that really works and is robust and is for the good of mankind. And it's also about solving some of the most fundamental problems of philosophy, of determining what is, on a global scale, what is reliable and what is not, what is good information and what is not, and also what is beneficial and what is not, what good means. And like all of this, I find it extremely stimulating, and it's been like a fabulous endeavor. And I hope I've been able to share a little bit the enthusiasm I have for this endeavor. And with this, I thank you for your attention.
Thank you so much. That was a very engaging talk. I am curious, there was a moment in the talk where you were talking about how to, I forget exactly the wording you used, but more or less define or ensure good actors in the system. We're already so far into this like polarized world of disinformation. Your early example of search engines, right? Like there are reasons why these other sites have so many hits for why climate change is a hoax, is because people want that and they're searching for that. And if they have a hand in defining how content is curated and presented to other people searching, they're going to want to boost that content. So I guess my question is, how do you work with the people who they do have these email accounts verifying that they're a real person, a valid contributor, but their scope of what they want to boost is outside maybe your values, my values,
Yeah.
factual grounding, that kind of thing.
Yeah. So yeah, it's already hard enough when it comes to factual information. It gets like completely a mess when it comes to more like values or moral considerations. So I think there's a very interesting example, and it's the case of Taiwan. So Taiwan used to be like quite polarized, a democracy that's quite polarized, but they've made a lot of efforts, especially they designed these platforms where people could interact. Actually, they reuse a platform called the Poll.is. And this is a platform that has the specificity of always promoting consensual information. So if a lot of people vote this, and also they do some Bayesian analysis to infer, like, it's not like they look at, I think, so I haven't looked at all of the details, but I think that they're looking at how similar different people are. And if they see that like a content is 100% likes, but from a small community, like it's not representative of everything. And so they try to infer like how consensual for the entire community a different information is, different claims or different messages are. And this promotes views that are more consensual. And this allows to make a lot more progress. And also it calms everybody, because if you're always pushing like controversial topics, everyone is always in the like defense mode, like trying to argue. And I think this is really showing that there's a lot of progress that can be made this way. And in the sense that also what we're trying to do on Tournesol, like the videos that are going to be better rated, are probably going to be better rated because a lot of people will be agreeing that this is a content that, for instance, discusses all sides in a fair manner, shares all the, like, is quite complete in like it's still manning like the opposite sides and stuff like this. And so the hope is that by promoting more of this content, you can also reduce polarization. But yeah, this has to be verified eventually.
Awesome, thank you. Other questions? Feel free to just hop in.
Yeah, thank you so much. That was really, really interesting. One of the reasons that the sort of existing model is so powerful is that you can describe the objective function very straightforwardly, right? They're trying to maximize engagement. In a Tournesol-like model, is there a like comparably pithy way of thinking about like what the objective function is? Or is part of what you're doing the idea that you can't sort of reduce it as simply as, and whenever you try to reduce it, you're gonna end up with some unintended negative consequences?
Yeah, so well, I guess one thing I should stress is that I think the main contribution of Tournesol is not a recommendation algorithm. It's not like actually solving the alignment problems, not computing this goal. What we're really trying to do is to create the database. I think this is an important first step. And what we're hoping is that based on this, other researchers, like research, like AI research or machine learning research, I'd say, is really based on the idea that you put out there a database and a lot of people will be using this to optimize their algorithms, and there will be new ideas coming up. So that's really what we're hoping. Now, of course, I'm also interested in the question of how do you actually build this algorithm, and how do you compute an objective function based on Tournesol's data. Like the basic version we have here is like this Tournesol scores, like we give a score to the different videos, and you can think of this algorithm as being happier when it recommends videos with a larger score. I think this is a good first step, but it's nowhere near good enough. And hopefully there'll be more exciting research to figure out how to do this. Does it make sense?
And yeah, totally. And the data in that database is those 6 different sort of individual scores, right, where you disaggregate it for unintended consequences and pedagogical use and stuff.
Yeah, so the raw data is like the contributor's judgment. So like for each pair of video, he's going to say which one is, and so we hope to collect like a large number of these kind of small comparisons, and
Awesome. Thanks.
We're at the hour here. So let's take any last maybe one or two questions if there are any, and then we'll wrap up.
I'm just curious about, as you scale this out, how would you see gathering representation of the population in general? Like, especially I'm just thinking of, individuals who might be more conspiracy theory minded and them feeling like they're left out of the process of selecting results.
Yeah, that's a very good question. It's very hard to commit to work around this issue. Yeah, so maybe relatedly, there's another concern that we have is that people who do engage with this kind of platforms are usually geeks, like people like myself, I guess, who watch a lot of these kind of videos. And like I can see, for instance, in my statistics on the YouTube channel, it's 94% male. There's going to be a huge bias, unfortunately, on Tournesol as well. And so, like one research direction I'm currently investigating is that the idea, well, intuitively, the idea is that you would give more voting rights to those who represent underrepresented communities. So yeah, I'm trying to work out to formalize this idea. And so actually more precisely, the way I'm trying to formalize this is the idea that you would give every person on earth a basic voting right, but then you know that you don't really know the voting rights of many people. And so you have large uncertainty of those who have, if you have no data about someone, then you have a large uncertainty. But usually you always have some, in a sense, you always have some information, at least you know like half of the people on earth, around half of the people on earth are male, this kind of information. And then I work out a Bayesian model to try to leverage this kind of information and to guess what the result of the vote would have been if everybody had participated. But then regarding conspiracy theory, there's another issue is that typically on a question like vaccines, typically you may want to give more importance to those who have studied a lot of the topic, experts in vaccinology. Yeah, again, so this needs to be formalized in a sense. So what I'm hoping is that, so right now, to my knowledge, there's no research that tries to do this, like to try to quantify the voting rights that an expert should have compared to the others. But yeah, I'm also working on models that try to factor this. That essentially would have to do with how different people judge the reliability of different people. That's sort of the basic ingredients of the kind of models I'm thinking about.
One question that was just sent to me in the chat is, do you think Tournesol will be as profitable to implement as the current sentiment spiral algorithms? I understand YouTube is still underperforming, so perhaps there's an opportunity.
Yes. Yeah, well, YouTube, I think, is still underperforming, so yes, there's that. But like I do expect that there's going to be a cost for YouTube so typically one idea I would have in mind is that, especially at the beginning, at least like one video out of 5, let's say, or like results of the Tournesol recommendations rather than the YouTuber recommendation. But if YouTube does this, like I do expect a small decrease in user engagement and stuff like this. And so it's going to be a cost. So if there's no social pressure or legal pressure on Google and YouTube to move towards things like Tournesol, like I don't think Google will go for this. And so I think it's really important to build more pressures, especially social pressure initially, on these platforms that to show that they have a responsibility, and that today, like I would argue that at least hundreds of thousands of people have died of COVID because of misinformation that was spread on YouTube. And so the more people agree that YouTube is killing people, not intentionally, but because of unwanted side effects, and the more people believe that YouTube has a responsibility in terms of public health and also national security, I would argue, the easier it will be to create all the social dynamic changes within Google and outside of Google to lead to Google actually implementing solutions.
I think it's really helpful to remember there are things going alongside the technological developments to make them more high impact and relevant. And so I will be sure to include information in the video description to help folks connect more readily to you and to this project. I'm very excited about where this is going, and hopefully we can stay in touch. Just a quick note to those folks who are watching the recording on YouTube, please remember to like and subscribe and share this video. Our next talk is going to be April 6th at 1700 UTC from Christopher James, who's a professor of biomedical engineering and the director of the Biomedical Engineering Institute at the University of Warwick. His talk will review the state of the art in brain-computer interface and address questions about BCI, like what can it do for us? How can we create good BCI, brain-computer interface, etc. If you want the Zoom link to join future talks and to subscribe to our newsletter and other announcements like funding opportunities, etc., you can join our mailing list in the footer at research.protocol.ai. Thanks for joining, everyone. We'll see you next time.